Okay. Uh, I forgot to mention one thing. Okay. Like we have like 16 weeks plus 2 weeks this semester, right? So one student just came to me to ask about like the I mean the date of the final. Okay. I plan to have the final on the in the 17th week, 17th week. Okay. And this semester I have like one trip to Thailand, okay, for a workshop, and another trip that is that will be planned, okay, but it's not known yet, okay. The trip to Thailand is going to be in the middle of March, okay, in the middle of March, but it's not going to affect this class, okay. The only difference is that week we are going to have the class online, okay, because I'm not going to be, in Taiwan, so we are going to, do the lecture online, okay. The other trip, if it is like determined, okay, I will tell you guys in advance, okay. But as I said, okay, I'll try my best to, keep the class going, okay. So let me repeat, okay. The final will be on the 17th week, okay, on the 17th week, okay. 就是我的 philosophy 就是，反正学校16周嘛，那16+2，他给你2周丢给老师说，那你就看你要不要教。我感觉教18周好像我有点亏，教16周好像觉得又对不起你们，所以我就折中一下，这中庸之道就17周这样子，这样应该 OK 嘛？你们我知道说有些同学说会安排那个行程，应该也是第18周以后吧。OK， 我们的学期已经够短了。那个by the way， our university will officially move to 16 weeks per semester, starting, next semester， 就是下个学期开始，我们学校就会正式变成一个学期16周哦，没有那个+2的那个弹性上课。OK。Okay, so back to this class. Okay, I know like this is the first lecture, but I hope to be able to cover something. Okay, yeah, I will try to be quick. Okay, so so this course is analysis of the algorithms. Okay, so supposedly this subject is about the theoretical study of computer program performance and the resource usage. Okay, but there are many other important factors. Okay, that of course we are going to address some factors in this class. Okay, but there are some other factors that we may not, be able to address in this class. Okay, so for example, okay, modularity. Okay, this is usually covered by software engineering. We are going to talk a little bit about correctness, actually. Okay, but we are going to focus more on the performance. But of course, when it comes to algorithm design, you have to make sure it's correct, right? So, but we are not going to teach you like a lot of like formal method, okay, to prove the correctness of the program, but some basic idea to correct that, to argue the correctness of a program will be, will be talked about, like in this class, okay. And the maintainability, again, this is about more, covered by the software engineering, and the functionality, okay, robustness, okay. They are, again, some may be covered by the software engineering, some may be, more like user experience stuff, okay? So, and user friendly, okay? This is more like a HCI, okay, human-computer interaction part. Programmer time, okay? We are going to talk about the program performance, not the programmer performance, okay? It may take a programmer a lot of time to create a very efficient program, but maybe that programmer is just doing things very slowly, okay? So the programmer time is not going to be measured in this class. And the simplicity, okay? There are many ways to do the same thing, okay? Some may be simpler, some may be more complicated, but we are not going to talk about that in this class. Extensibility, again, this is more like in the area of software engineering. Reliability, there's a, reliability is part of, some people consider that's like, one aspect of like security, okay? But anyway, we are not going to cover that in this class, okay? So why do we need to study the performance of algorithm, okay? Because this class will help us to understand scalability. What is scalability? Okay. A lot of time when the problem is small, okay, you can always like create. I mean, you can write a program that, solved a small problem, very effectively, no matter which approach you take, okay, because the problem size is small. But when the problem size become bigger and bigger, okay, the program efficiency becomes, or like the performance of a program becomes an important issue, okay. So that is what we meant by scalability, okay. When the problem size, increase, okay, how fast your program can perform the task, okay. So the performance draw the line between what is feasible, what is impossible, okay. So when the problem becomes like to a certain size, okay, some program can still get the job done. Some program is not possible, okay, because it takes like forever, okay. So this is especially true, okay, when the order of the program is, the type complexity, okay, of the program, is different, okay. We are going to talk about that in this class. So algorithm, we are also going to talk about some specific mathematics, okay, which provide language to talk about like the program behavior, okay. Remember I just mentioned about like complexity, right? How do you use like a mathematical term to measure the complexity, okay? That is something that we are going to talk about next lecture, not this one, okay? This one we're going to just touch a little bit. And performance is the currency of the computing, okay? When you use this word, it looks like Nowadays, I mean, whenever you talk about a computer, probably the most expensive part is the GPU card, right? But the CPU become cheaper and cheaper, okay? But in reality, okay, if a program takes like 1 minute to finish or 10 minutes to finish, it may not make too much difference to you. But if a program takes like days to finish, then you may feel like it's it's not acceptable, right? So as I say, like when the problem size become bigger, it is this situation may may occur. So that's why like we need to consider this. Okay, otherwise like if you want like a faster, I mean the test to be done quickly, I mean one way is you can buy a faster GPU. That I mean CPU, of course, is more expensive. So another way is to design more efficient algorithm. Okay, so which save money, right? So you can consider this as a efficiency of computing, like as a performance as the currency. Okay, so lessons of program performance generalized to other computing resources. So we talk about the time here. I mean, the same idea can be used to measure, for example, like storage consumption, or like number of message, because I mean when it comes to like a parallel computing, okay, I mean the number of message passed between different CPUs, different like computing units, okay, can also be used to measure the performance. Okay, so there are all these like tools that we use to measure the performance of the program can be used to measure like whatever computing resource that is consumed by the program. Okay, the last one, obviously, if you can write a faster program, well, it's fun. So as a starter, okay, let's consider the sorting. Okay, a very simple sorting algorithm. Okay, so in this class, okay, we every time we talk about a problem, we have to specify the input, specify the output. Okay, so for the sorting, okay, we have a sequence of numbers. So A1, A2, blah, 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 AN, we have n numbers. So the output will be the permutation of these numbers. So this A1 to AN, they are actually, this set of numbers is exactly the same as the set of the number here. A1 prime, A2 prime, blah, blah, AN prime, okay? These two set of numbers are the same. It's just, I mean, the order is different. The order is different because the second one is the permutation of the previous one. So after the permutation, the A1 prime is smaller or equal to A2 prime, which is smaller than or equal to A3 prime, and so on. Okay, so largest one is AN prime. So this is, I mean, we consider it is sorted. Okay, this is a definition of the sorting the problem. Sorting problem. The input is this one. Output is this one. If we give an example, this is the input, A24936. Okay, and after we finish the sorting, the output should look like this: 2346A9. So this is a permutation of the previous 6 numbers, but they are in ascending order. Okay, in ascending order, 就是递增的。So far so good, right? So how do we sort the numbers? Actually, sorting, okay, this problem can be considered like as like one of the most fundamental problems in algorithms. There are so many different sorting algorithms out there. Okay, there are what we call simple sorting algorithms. There are what we call advanced sorting algorithms. Okay, so how many? You guys must have learned some sorting algorithm previously, right? Like a bubble sort, right? Okay, like a selection sort, right? I mean, in your data structure, you should have learned bubble sort and selection sort. I don't know if you have learned insertion sort from like a previous classes. Yes or no? No? Raise your hand if you have learned the insertion sort. Okay, good, good, good. So some of you have like some the idea about like insertion sort. So what happens? So this is a pseudocode. But before I talk about the idea, okay, I would like to tell you, okay, a lot of sorting algorithm, okay, the best way to understand the sorting algorithm is by the poker cards. I mean, you guys must have played some poker games, right? 你们一定玩过一些扑克牌的游戏嘛，对不对？大老二，那个13张，对，玩过吗？玩过嘛，对不对？你知道我那个大学的时候，我毕业的那个你们还没我知道你们大多是还没毕业啦，大学还没毕业。你们毕业的时候会有那个毕业的那个什么，那个纪念册嘛，对不对？啊，每一个人不是有一张照片，那可以写几句话吗？对不对？在上面，我的毕业纪念册，我那一届我毕业纪念册，我的照片，我左边跟右边上面写的是那个黑白围棋大老二，右边是什么？那个忘记了什么象棋13张，然后横批百战百胜。对，我大学的时候超爱玩各式各样的这种游戏的，包括那个这些那个 poker game 嘛，对不对 ？So when you are given because你一定是洗牌嘛，洗完牌以后你发牌你拿到一手牌 ，What do you do after you get your cards? You sort your cards. 对不对？你会把你的卡排序，对不对 ？So there are many different ways to sort the cards. Okay, if you don't like poker games, you play 麻将 right? I mean, when you get your 这个麻将的这个牌，你还是要排序嘛，对不对 ？So you do the sorting all the time in your daily life, okay? But you just didn't really like realize. I mean, you have implemented different sorting algorithms, previously, okay? So how do you do the how do you sort the poker cards? Actually, the insertion sort is perhaps like one of the most simple, concept to sort the poker cards. Okay, 就是the concept is like this. Okay, you try to you try to find the smallest one, and you put it at the beginning. Okay, so this car has been sorted. For the rest of the car, you find the smallest one, put it in the second position. So the first position, the second position has been sorted, right? So you repeat doing this until you finish the sorting. OK， 就是就是你拿到一手牌嘛，你把最小的牌放到前面，第二小的牌放到第二张，第三小的牌放到第三张。就我不知道，很多人牌卡都是牌扑克牌都是这样子排序的。当然有一些同学可能不是，可是我会相信，可能有超过50%的同学是这样子排的。OK， 那 this is insertion sort. This is insertion sort. But of course, like in reality, I mean, when we implement it into a program, then we have to be more specific, right? We need to put down, like, put our concept into like lines of code. Okay, so but the basic idea stays the same. So you can see that, okay, assume this part is already sorted. So we find like smallest one and put it in the right position. Okay, so the concept is exactly as shown in this figure. Okay. So, and there's also like something that I would like to talk about here. Okay, so this is what we call pseudocode. Okay, in this textbook, okay, the way we discuss the program is to use the pseudocode, okay, which is like more like a programming language independent. Okay, it is not exactly, it's not C, it's not Python, okay, but the structure is similar. The structure is similar. Okay, you see like a for loop, you see like a do while loop. Okay, and we have like a proper indentation there. Okay, to help you understand. Okay, so it shouldn't be difficult to understand the pseudocode. Like if you at least know one programming language. Okay, although like we don't use the programming language, I think like it should be reasonable. Okay, to assume. Okay, in this class, once you understand a pseudocode, it is relatively easy to convert the pseudocode into the programming language, whatever programming language you are familiar with, either C, C++, Python, Java. Okay, it doesn't matter. Okay, it doesn't matter. So, and also, okay, by the way, I also have a project, okay, that my student is working on. Okay, we are trying to use the large language model to generate like the program, okay, from pseudocode. Okay, I hope like I will create. I mean, after the finish of this project, I'll put like this tool on to use. Okay, in our algorithm class. Okay, so that like it can be a tool for you to to experiment on some pseudocode and which help you to generate like a program, and you can run your program to see like how the pseudocode works better. Okay, but that's another thing. At least I don't think like you guys will be able to see that this semester. Hopefully like next semester. Next year. I mean, if we spend time to finish the creation of this tool, like next year, okay, the next time I teach this course, okay, I hope like I have like a tool like that, okay, for my students. Okay, so anyway, so let's come back to this code. Okay, so you can see that. Okay, so first, okay, we specify the input, okay, as like a parameter to pass into this. You can say that this is a procedure, okay, insertion sort, okay. It has an A, it has N, okay, which stands for like an array A, okay, with N number of with N numbers in it, okay. By the way, okay, I know like different programming language has different starting index for an array. Okay, for example, like C, C++, I think the index starts from 0, right? Okay, but in this course, in the pseudocode, okay, the index starts from 1, okay, in an array. Okay, so keep in mind, okay, this is like what we are using in this class. So for j from 2 to n, okay, do key equal to aj, okay. So this is like, if you have only one number at the beginning, it's already sorted, right? It's already sorted. Think about that. If you have only one number, it cannot be not sorted. What do you mean by a number is not sorted? Just one number. 如果你有一张，你有一个数字，那个数字就只有一个数字，那个数字可以是不被排好的吗？啊？一定是排好的嘛，对不对？对，因为要不排好，一定是至少两个东西，两个数字才可以说它没有排好，对不对？如果是一个数字，一定是排好。所以我们 That's why we start from 2, okay, index 2, because we assume the first number has been sorted. Okay, so it is the rest of the part that we need to find some other thing. So the rest of the part that is unsorted. So you can see like this part is sorted. The other part is unsorted. So the idea is like, it's just like, at the beginning, this part is just one number. OK， 因为就只有一个数字，就不可能是没有排好的嘛，所以我们第一个数字是排好的，其他是没有排好的。OK， so from 2 to n. OK, so we start from, so key is 2. So this is, at the beginning is index 2. OK, so then we, I is like j minus 1, which is obviously this location. Okay, this location. I mean, at the beginning it will be index 1. Okay, I mean otherwise, if you have passed the first round, first loop, then it's the previous. Okay. 我可以把，因为这个等我一下，我先把关掉好了。Okay. So while I greater than 0 and the ai is greater than key, okay. So basically, okay, we see this number, and then we find the right place to put this number into the sorted part. Okay, so we will push these numbers one position to the right if these numbers are larger than this number. So it's kind of like you have some cards here that are sorted, and then you have a new card here. You just need to find the right place to put that card into the sorted list. So of course, when you put this card into the right place, location, I mean, if it's a poker card, you just insert it, right? But if it's an array, you have to, move these numbers one position to the right in order to clear a space for this number to put in, right? 就是如果说你是一手牌，你就是把它插进去就好了。但是如果说是这是一些数字在 array 里面，你必须要把那些比较大的先把一个一个往右边移一个位置，让这边有个位置可以把这个数字放进去嘛，对不对 ？So once you put this j, the index, the number in the index j, into the right place, so this part has been sorted, right? This part has been sorted. So you start consider the next number. So you keep doing that, you keep doing that until you finish the whole array, and the whole array is sorted. The concept is exactly like you are sorting a number of cards in your hand, okay, a number of poker cards in your hand, okay. 至少对大多数的人来排那个扑克牌的卡的话，是大概是像这样子。So far so good, right? So let's have a look. Okay, I mean I just show you this A24936 example, right? Previously, this one A24936. So let's see how this A24936 can be, rearranged into 2346A9 by this, insertion sort. Okay, so in the first loop, as I said, we start from the first number, so A is already considered sorted. So the J start from 2 to, the rest of the index. So obviously, we will compare 2 with this one. So 2 is obviously smaller than 8. So we move 8 one position to the right and put the 2 there. Okay, so it's actually, when we do this, actually what we meant by is like we move 8 one position to the right and move 2 to here. Okay. So we get like 2, 8, right? So this part has been sorted. Okay? And then now we consider 4. So we compare 4 with 8. Obviously, 4 is more than 8. So we have to move 8 one position to the right. And then we consider 4 with 2. 4 is greater than 2, so we stop and put the 4 here. So that's it. Okay? So you see, we find the right place for 4. So we put the 4 there. The result will become 2, 4, 8. The first 3 numbers become 2, 4, 8. So this 3 number has been sorted. And then we consider one more number, 9. Okay, and when we compare 9 with 8, it's already been sorted. Okay, because 9 is greater than 8, so nothing needs to be done. Okay, so then we consider next number, okay, which is 3. So we have the first 4 numbers sorted. We consider 3. So 3 is smaller than 9, so we move 9 one position to the right. So 3 is smaller than 8, so we move 8 one position to the right. 3 is smaller than 4, so we move 4 one position to the right. So 3 is greater than 2, so we stop and put the 3 here. So that is what happens. So we have like 2, 3, 4, 8, 9, 6. And we do similar thing for 6. So the result is like this. So far so good, right? Okay, so that is the insertion sort. Okay, The idea of the insertion sort is that you have this part as sorted. So every time you just keep adding one number into the sorted portion. You just grow this sorted portion until the whole array is sorted. Okay, that's the basic concept. So once you understand this basic concept, of course you also understand the correctness of this algorithm. Right? So this algorithm is obviously correct. Okay? So,看起来是要没电啊。So we know the correctness now. So now we need to discuss the running time, but I think it's time for us to take like a break. Okay, 10 minutes break. Let's take 10 minutes break. When we come back, let's continue the discussion of this the running time of this algorithm. Okay.